Okay, this is a pretty confusing problem, but it says a pharmaceutical company receives large shipments of ibuprofen tablets and uses an acceptance sampling plan. The plan randomly selects 12 tablets from the whole shipment, then accepts the whole shipment if there is at most one that doesn't meet the required specifications. So either zero are defective or only one in the 20 is defective. So what is the probability the whole shipment will be accepted if a particular shipment of thousands of ibuprofen tablets actually has a 13% rate of defect? So we're looking for the probability of an accepted shipment. Whoops. So that's the same thing as saying the probability of 0 or 1 defect, which is the same thing as saying the probability of 0 defects plus the probability of 1 defect. So if we just find these two probabilities and add them together, we should be good to go. So I'm going to start by just listing out. We have 20 tablets. I'm not going to write them all out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ... So there's 20 tablets here. What's the probability of 0 defects? Well, that would mean the first one can't be defective. What's the chance that the first one's not defective? Well, that would be 0.87. The chance the second one's not defective would be 0.87. The third, 0.87. And you'll see that it would just be all of them would be 0.87. So this would just be 0.87 to the 20th power because there's 20 tablets. So let's do that. 0.87 raised to the 20th. We get 0.0617. Now the probability of 1 defect. Well, it just changes a little bit. Let me do a different color here. Let's say, what's the probability the first one's defective? Well, that's going to be 0.13. So then the first one's defective, the rest are not. So it would be 0.13 times 0.87. Now it's the 19th power because we have one that's defective and 19 that are not. But this can happen in how many different ways? Well, the first one can be defective. The second one can be defective. The third one can be defective. So at any given point, any of the 20 could be the defective tablet we're talking about. So this can happen in 20 different ways. Okay. This will become more clear once we get to the discrete probability distributions like binomial. This is technically a binomial distribution. It'll become much easier once we've defined it as such. But to find that probability, I'm going to do 0.13 times 0.87 to the 19th power times 20. So I get 0.1844. So to get the probability of 0 and 1, just going to add these two numbers together. So I'll take that plus that, and my answer is going to be 0.2461.